Hey, hello, all you wonderful people out there. Hey, Dr. Metis here. Today I want to talk to you about stoichiometry. It's a cool little word. It always comes up in your spell check as not spelled right, or you got to add it. All right, it frightens the snot out of a lot of people because it can get complicated, but really you got to go with the basics that you know. You know chemical reactions, that they have to be balanced, that there are ratios between all the guys, all the little species in the chemical reaction. And you know there are conversions. All that is putting a lot of this together. And usually when things get put together, you really got to take your time and sort of walk yourself through the steps. Stoichiometry for like a lot of high school teachers, man, is just they really are talking about, three parenthesis type conversion problems. But technically speaking, we already did stoichiometry in the previous video because it's anytime you do it using the relationship from the balanced chemical equation. And when you did mole to mole conversions, you used the mole to mole relationship from the balanced chemical equation. That's part of stoich. Alrighty, so let's just dive into it. With that mole to mole, here's what we did in the previous video. You converted moles of phosphine to moles of water by first setting up all the letters, all the given and the wanted, and then plugging in the coefficients of 6 and 4. Okay, we can make this more complicated because instead of being given moles, what if you were given grams or something else that you'll learn how to calculate later, but right now it's just grams. What if you were given grams or maybe molecules? You had to convert, but more likely grams. You had to convert grams to moles, all right? Then you could convert mole to mole. Option B, what if you don't want moles of water? What if you want grams of water? Okay, well, that's just another conversion step that you're going to do. So we're going to walk you through all those conversion steps. Don't panic. It's a lot of just putting stuff together. No big deal. All right. So here are your conversion factors again. All right. If you notice, thing that I wrote, you notice is mole goes with everybody. Okay. Because what you're often trying to figure out in these multi-step problems is what units to put in. All right. Look for the one typically that isn't moles. Because on the unit is other one is moles. So with grams, the other unit's moles. With molecules, atoms, electrons, some type of particle, the other unit's moles. If you notice for this lovely last one, that's the only time you're going to have two different chemical formulas in there. That is the ratio of mole to mole. That's what you have to do to convert from one chemical formula into another chemical formula. They only relate through the moles. So if you want to convert grams of one thing to to grams of something else, if you want to change chemical formulas, you got to go through the moles. So let's start. Let's get at it. Alrighty. Let's say we want to get just in the general schematic, A plus B to get to C. If you want to go from moles A to gram of C, you can't do it in one step. First, you got to do a mole to gram conversion. And students that don't write chemical formulas try to do it in one step. In a mole to gram conversion, they're all the same chemical formula. We need to change chemical formulas, so that tells us we have to go through moles of A to moles of C. We have to do that conversion. So somehow we got to get that in there. Then we can get the grams of C like I was talking about. Alrighty. So there's your thing that I'm saying you can't do. If you just, and the thing is you don't have to know you can't do it. You just set up your given, set up your wanted. Given goes down, wanted goes over. And you try to figure out the numbers that go in there. You go, oh, it's not. I can't do that. I got two different chemical formulas there. What am I going to do? Well, separate them. Don't panic about it. You separate them and go, okay, now what? What unit can go in both spots? What unit can go in here and cancel out? What unit goes with moles? Everybody. So forget that one. What unit goes with grams? Moles. It's grams of C, so it has to be moles of C. And then, so that you can cancel everybody out, that puppy's going to go up there already. And then you can have all the letters set up so that you have an equality. Go get the numbers. This is your given. This is your mole to mole ratio. You get that from the balanced chemical equation. This is your molar mass. Alrighty. I was going to say that's the thing that we outlined earlier. Woo! But yeah, let's just move on. Here's a real example. Okay. I can calculate the molar mass of C. I don't know what I was thinking. If we go from grams of aluminum to moles of aluminum oxide, generally speaking, we need to do three steps. Because to go from grams of one thing to moles of something else, we have to change the chemical formula first. So change that chemical formula. Then do the next step. So that's going to be a two parenthesis type problem. Alrighty. So we get put in our given. It goes down. Grams goes over. It's always nice to sort of know how many parentheses you got, because then you can sort of sketch out the black parts that are writing it, sketch out the parentheses, and then write in all the red and blue stuff. Okay? It's just, to me, it's easier. Then you go, hey, what goes here? What can go here? It's got to be the same thing so they can cancel, hopefully. And what goes with moles? everybody, so focus on the grams, that's got to be moles of aluminum. Cool. We go to the periodic table, get moles of aluminum, grams of aluminum, 26.98. And then we get our coefficients for the balanced chemical equation for the mole to mole. A lot of students see that this is always 1. So back up here, the habit that you're going to get is every time you see mole, you're going to slap a 1 in there. Don't do it because over here it's not 1. Okay. Another group of students does the opposite. They say, hey, it's always the coefficient in front of the moles. So what I end up getting is coefficients here, but this puppy here is the coefficient. When you want to do the numbers, focus in on the parentheses. It's just whatever's inside the parentheses. The first parentheses of mole to mole relationship, that's coefficients. Focus on the second parenthesis, screw that, okay? Focus on the second parenthesis, that is gram to mole, that's the periodic table molar mass, okay? It's kind of like if you're chit-chatting with somebody, just look at the one person you're talking to. Now look at the other person you're talking to. Don't focus on the whole thing. Do another one. We got grams of oxygen from mole to moles of aluminum oxide. How many moles of aluminum oxide? So many grams of oxygen. You know it's going to be multiple steps because the unit's got to change and the chemical formula's got to change. So how many steps? Well, jot it down. You got grams of O2 going to moles of O2 to moles of aluminum oxide. Should be 2 steps. So write down your given and your wanted. 7.50 grams of oxygen goes down. 1 is going to come over. How do I know the green stuff that goes in there? What unit always goes with everybody else? Mole. The unit that goes with mole is anybody, but the unit that goes with something else is always moles. Okay? Typically the unit that's missing is moles. So what can go with grams? Moles of O2, because moles of O2 goes there, it goes there, then all your units are canceling. Now you got to figure out where the numbers come from. This is your molar mass, this is your periodic table number. This coefficients. How do I know that? Mole to mole. Okay. Molar mass of oxygen, you got 2 times 16 for your 48 per 1 mole. 2 to 3 are the aluminum oxide and the oxygen. Then I crank through the math. One more bigger problem. We got grams of one thing, 16 grams of aluminum oxide. How many grams of oxygen? So we want to go from grams of one thing to grams of something else. There is no gram to gram conversion. The only way you're going to change chemical formulas is through moles. Okay? So go to moles, change the chemical formula, go up to grams. Okay? There we got it all sketched out. You know you're going to have 3 sets of parentheses when you go to do it, so just write out your 3 parentheses. Don't try to write it like an English sentence left to right. Just leave yourself space. It's not a big deal. It's going to take up a whole line on your paper. It's okay. Just leave yourself space. Make this like the blue line of your paper. Put the top in one space, bottom in the other space. Don't squish it. Make it nice and easy to see, man. Okay? Given goes down, 1 it comes over. You now got to figure out what goes in these spots. Well, the middle's kind of hard, but what goes with grams? Moles. Moles of the exact same thing. Alrighty? Now, if you cancel out moles of aluminum oxide, cancel out moles of oxygen, you'll end up with a mole to mole ratio in there, which is cool because mole to mole ratios use coefficients. Okay? Mole to gram, gram to mole, that's molar mass from the periodic table. We can just add that puppy up, you know? Not a big deal. How do I know that these are 1s, but these are not? Because I'm looking inside the parentheses. Gram to mole relationships, mass of 1 mole by definition. Gram to mole relationship, mass of 1 mole by definition. Okay? When it's a mole to mole relationship, like in the middle parenthesis, that's the coefficients. If you look elsewhere, some people will talk about ratioing, molar, do all these weird little ratios and all this other junk. This is the most straightforward way to do it. It's really important that you see to change chemical formulas is only done through moles because that's applicable to all the other work you're going to do in your chemistry classes. It's not some shortcut or anything like that. All right, the whole idea of working with the units is applicable to everything you do in your chemistry classes. So you really want to get that down. Alrighty, so learn it, like it, love it, all that happy nonsense. Take care, and I'll definitely talk to you later.